Hey there, we're going to go through the 2024 exam solutions. We'll start with question 1, and in this question we've got a dog grooming salon, and you can see here that there are 4 different tasks that needs to be completed in order to groom the dog. Throughout this question, we're going, by the end of it hopefully, we're going to try to minimize the total completion time to groom the dog based on the average time spent by each staff member to complete a task. So starting off with the first question, it says, well, let's interpret what the table's actually saying. In fact, what does that 25 mean? And we can see here that has to do with Owen, and it's going to be Owen takes, in this case, 25 minutes to dry and brush a dog. And then we go down getting ready for part B. Now, part B, they've given us a little bit of information beforehand, and I've just kind of written around there just to help us out with the allocation. But it's saying it's already in a reduced array, and it wants us to start allocating the tasks to the different staff members. Now, when we go to allocate, we're looking for having only 1 0 in either a row or a column. And so if we go to the first column here, we can see that Owen is going to be allocated to washing because it's the only 0 in that column. And then we're going to keep going across. So column 2, there's only 1 0 as well, and that's going to be for Delilah, and Delilah is actually going to trim the dogs. Third column, well, we've got 2 zeros there, but we can't actually allocate Owen to drying because he's already been allocating to washing, which means that he comes down, the person who's going to dry is going to be Zafira down here. In the 4th column, we have the same kind of scenario. We can't allocate Delilah to nails because she's already been allocated to trim. So that means that Gracie is going to have to do the nails and teeth of these dogs. So we, when we get down to the table below in B, we're just going to fill in that information, and we can see that Delilah again was trimming. Owen we already wrote down as wash. We've got nails, ankles and teeth, and then Zafira is going to do dry and brush. Now for the time taken, we don't go to the reduced array, we have to go up here to the other one, and we're seeing that Delilah to trim is going to take 40, Owen to wash is going to be 33, and nails and teeth for Gracie was 22, and Zafira is going to be, I think, 26. Those numbers are then just going to quickly be put into the calculator to add up, and we get 121 minutes here. So just make sure that we always have units throughout the exam when we actually know what they are. They have to come down to our answers. Next page. The manager wants to do a campaign, and they want to do the dog in under 2 hours, or the next groom is free. Now that sounds a little bit ambitious at this point, because we can see up here that at the moment they're claiming they take 121 is the best time that they can actually get for the completion time. So 120 minutes is equal to 2 hours. So I've got that 1 minute there that's just not going to work out for them. So in order to see if they can get a better completion time for all those 4 tasks, they're going to try to allocate Gracie an extra job, and you can see down here she's now got an extra row in that table. So go on ahead, and they've got a new array to kind of represent this information, and we've got this dummy column here, and that's because now we've got essentially 5 employers but only 4 tasks. I've just pre-filled this, but the new array must have an additional column of zeros, and then I've said because it needs to have a square matrix to apply the Hungarian algorithm. You could also say to have the same number of rows and columns. So they've gone ahead and they've done the first 2 steps of the Hungarian algorithm. First 2 steps means they've done a row reduction and a column reduction, but they have not got the optimal solution yet. And so what they want us to do is say, well, let's just do the lines on here, which is the next step in the Hungarian algorithm, to see if we're ready to allocate, and to show in this case that it's not Now, when we do these lines, we're looking to cover the most amount of zeros with the least amount of rows. So if I can cover 3 here, then that's obviously a good line to do. I can't cover 3 zeros in one line again, but I can come over here and I can cover 2. I could cover 2 going across and then another 2 down the middle there. So I've essentially got here 4 lines, but I have 5 rows, which means I'm not ready yet to allocate with my Hungarian algorithm. The next page is actually asking us to complete the remaining steps of the Hungarian algorithm. And then there's a big and here, which means that we have to make sure we don't forget the minimum completion time that goes along with that. So I put my lines down from the previous page because that's going to help us to then go ahead and make our adjustments that we need. So we can get an extra line in here. So with the 3, we're now going to +3 and -3 where appropriate. So what I mean by that is we've got 3 spots where we've got 2 lines that are crossing over. At those points, we want to add 3, which is our smallest number uncovered. At anything that's not covered up, we want to actually -3. Now, you don't need to necessarily write the plus or -3 here, but I just find that it's easier for me when I come over to the next step so that I don't forget anything and I'm adding 3 and minusing 3 in the right places. Now, anything else, we're not going to move at all. So for my first, if I'm going across my rows here, I've got 2 + 3 is my first one, which is going to be the 5. The 0 stays the same because it's just a covered number. It's not double covered with 2 lines. And then 11 + 3 is going to be 14. The 0 again stays put. And then 1 + 3 is going to be 4. The 2 doesn't change, but it's going to be 10 - 3 now, which is 7. We've got 0, and then 9 take 3 is 6, and 1. I might just pre-fill these now. Okay, so I've done all that. Now we're up to the point where we have to go and do the lines again. And this time, remember, we've got 5 rows, so we want to have the smallest amount of lines to cover the zeros. It has to also be 5. So again, I've got my 3 zeros out here, so I'm going to put my line through there. I can cover 2 by coming down here, another 2 here, another 2 in my first column, and then I've just got my 1 that can go down here. So this time I have 5 lines. And I also have 5 rows. And so I can actually stop and I'm ready to allocate. Now, the allocation, similar to above, we're looking for a 0 on either 1 row or 1 column. This one here has only 1 0 in that second column, so we can allocate there. Because we've allocated that 0 on the first row, we're going to cross off this 0 because that can't happen. There's on this row, oops, I don't know what happened there. This row, we've also only got 1 0, and which means we're going to allocate Owen to that task. But if he's allocated that task, then this person down here cannot be allocated to that task, which means there's only 1 0. So at the moment, Sophia is actually allocated no task because of that last 0. So we can keep going through here, and if Sophia is allocated no task, then Grace cannot be allocated no tasks for her 2 options either. Now at this point, you can see here both of these are Grace, and we do have kind of like 2 options here for Grace. So the first 0, or the first option, she can either wash, and then if she washes for her first task, her second task is a dry and brush, but then it's also vice versa as well. So because it's the same person, it doesn't really matter here. So when we come down and do the allocation, we're going to say, well, Delilah is going to trim. Owen will do the dry and brush. Sorry, and then Grace has got 2 options, so we'll come back to here. Sophia, we said before, had no allocation because she had the 0 here in that last column, which was a dummy column. And then Gracie's 2 options, Hopefully I said it right before. I've got a feeling I didn't, but the Gracie's two options now is the first column, which was the wash, or her other option was the option to do a nails and teeth, which is this one here. Yeah, and now again, because we got the circled the and before, we have to have therefore the minimum completion time. And I've actually already got that in the calculator over there before. So it's going to be the 40 plus the 25 plus the 32 plus the 22. And you can see that's 119 minutes. Okay, so the second one here is just saying it's no longer required. Well, we kind of answered that for ourselves in the allocation, so we're just going to quickly put Sophia down there because she's no longer allocated a task. Just this last one, if I can get my right highlighter. We're going back to the same question that we asked right at the start, and that is, can you groom a dog in under 2 hours, otherwise you get it free? Well, I think they're going to be pushing their luck here, and we actually said that it is considered a little bit unreasonable, and it's unreasonable again because 2 hours is equal to 120 minutes. But when we're looking here, we can say, well, we've got 119, and we've only got that 1 minute of slack time here, which is not really enough to leave you with a lot of confidence. So we'll just say something like this is only 1 minute less, so it's 119 minutes compared to 120. Doesn't allow time for mistakes or even grumpy dogs. Yeah, so I think mentioning the 190 minutes and then saying that there's no room for error here is going to get you that last mark. So question 2 is focused around the normal distribution, where we're looking at different markers for childhood development. So the first one is going to be walking, and we know that there's a mean of 14 months and a standard deviation of 1.75 months. So we're just going to kind of summarize that to start with, where we say X is distributed normally, and we're going to have our mean, which is the 14. Oops, that does not look like a 14. And then we've got our standard deviation of 1.75, and we just put that little squared symbol there, but the standard deviation is actually the 1.75. So part A, we want to know what proportion of children start walking between the ages of 10.5 and 14. So I'm just going to do a quick sketch of a normal distribution out to the side. We know that the mean is 14, so we'll put that where the peak is. And for this one here, we know 10.5 is less than that, and we're after this probability in between. So our probability statement is going to say the probability that X is between 10.5 and 14. Now, on our calculator, the way we're going to go to get that is we're going to go back to our main menu, and hopefully on your calculator, if it's been updated, you can go into here and get your distribution, and we want to go into a normal distribution. And we're going to start off by looking at, now we have to switch the tail because it's no longer great on the, so that's the left hand side tail, not the right hand side tail. The X in this, it's not even that, it's between two values, where we're going to have the lower value is the 10.5, the upper value is going to be 14, and the standard deviation in this case is 1.75. The mean is 14, and then we can execute. So I'll get this nice picture, and you'll see here that the answer is going to be approximately 0.4772, and then we'll keep it as 3 sig figs, so 0.477. Now, just really quickly, if you don't have that option on your calculator, the way that you might go and get these answers is to go into menu and then go into your statistics, which is number 2, And then in here, you're going to go distribution, normal, and then you're actually doing an NCD, and you can enter your data here. So in this case, the answer is 10.5 is the lower, the upper is 14. We have a standard deviation of 1.75, and then the mean is going to be 14 as well. And then when we execute that, we get that 0.4772. So depending on if you have that app installed on your CASIO, if you, no, it's not really installed, it's just an update that your calculator can have. Okay, so I'm going to go back because I'm going to use from now on, I'm going to use my distribution. And I'm going to be doing all my calculations in here. Okay. So we go through now, we jump around a little bit in this question. We jump between the federal government and the state government. We kind of compare the funding options. So for this case, we're now starting with our federal. And the federal guidelines recommend the state offer funding assistance if a child is not working by the age of 17. So down here, we're going to then think about what the percentage of children are that require funding with their walking. So we can, again, just do a really quick sketch to make sure we're on the right page with this. We've got the 14 and 17 is out here on our tail, and they're the people that are going to get the funding, essentially. So as a probability statement, we're going to say the probability that X is greater than 17. We want to find out what that is on our calculators. So we just have to change the option here for our tail, because now we want the left tail, which is F3. We're going to have X is going to be 17. We're going to have the standard deviation and the mean have been carried over, sorry. And we get here that it's equal to 0432. Now the question is saying percentage, so we have to times that by 100, and that will be equal to 4.32% when we do that. So 4.32% of children need federal government funding because they're not working by the age of 17 months. Now, we're kind of going a bit locally now. We're saying that, well, in South Australia, there's 19,502 births in 2022. We're saying how many of those children are expected to require funding. So we're looking for this keyword expected. So the expected number or expected requiring funding is going to equal to the proportion that we had above, 0.0432. So we don't use the percentage, use the decimal version. And we're going to times that by the number of births, so 19,502. So 0.0432 times by 19. All right, and that is approximately equal to 842.4864. And we're going to round that up to 843 children, since that last 0.4 of a child actually needs some funding. So in the next question, we're flipping, this says the state government provide funding for the oldest 10% of children that are not yet walking. So what we're going to be doing now in this question, is to calculate the minimum age that actually entitles from the state government. So the federal government is saying that they want them from 17 months, and we're just going to compare to see what the state government actually does. So again, just another little picture to help us. We know that average is 14 again, and we're out here at K, some value K, which has 10% in this tail. So when we write the probability statement, it's probably that X is greater than this value K, which we're going to try to find, and we're going to say that that's equal to 0.1. So from our menu, we're going to go down into distribution again, and we're going to select the normal distribution, and we've got that left tail selected already. The X value here it doesn't actually matter what this is going to be because we have to kind of edit it on the next screen anyway. So we'll just leave it as 24. We just want to make sure that the standard deviation and the mean are good to go. And we've got that 1.75 here. And then the mean was, I think it was 14. Okay, so next screen we're just going to edit, so just keep that in mind. So it's not the 24 here we want, but we want to go to edit that left-hand side, and we're going to say that's equal to 0.1, and then it'll adjust it so that it finds the K value. So the K in this case is approximately 16.24. So in this case, we'll just keep it to 16.2 months. So the state government is funding kids who are not walking from 16.2 months, and then the federal government is recommending that it should be from 17 months. So the state government is looking okay at this point. Oh, hence the next question that we've got here. It's saying, is the state government providing enough funding assistance? Well, we just answered that question. Yes, it is. And that's because we've got the 16.2 months that we just found previously, and that's less than the 17 months that the federal government was actually trying to recommend. So that's our justification. So we actually do need to make sure we've got some justification there on that in that comment box. Okay, now apart from walking, there are a couple of other markers for development, and that is your speaking age and your first molar tooth. And we can see with speaking age, they're saying, well, it's going to have a mean of 17 months and a standard deviation of 3, but for your molar, we should be seeing 14 months and a standard deviation also of 3. So we'll just do our little summary statements off to the side. So X is normally distributed, and we've got the 17 and the 3 for age, speaking age, sorry, and then X is distributed normally here, and then we've got the 14 and then the 3 for our molars. The diagram below is showing a probability distribution of 2 of our 3. So remember the third one was our walking from the previous page. And we need to say, well, which one here? Fill in A and B to identify which markers. So you can see here straight away that they've got different means. So one's got a mean of 14. The other one has probably got a mean of around 17. So it could be either of the ones we can just see on the page here, which is speaking and molar. But the problem is that both of these ones have the same mean, which means that if it's the same mean, then same standard deviation. If they've got the same standard deviation, they're going to have the same heights of their graph, which these guys don't have. So one of them has to be walking, and walking, if we remember, had a lower average. So this one has to be walking because of the lower average, and it's got a smaller standard deviation because it's taller. So smaller standard deviation since taller graph. So if that one is walking, then the other one has to have the mean of 17. Only one had a mean of 17 anyway, and that's your speaking. So B has to be speaking, and it had a standard deviation equal to, was it 3? And then this one had a standard deviation which was smaller, which is 1.75, hence the taller graph. Okay, and then we've got to draw the missing one. So we're drawing the, I just changed my pen, drawing the molar, which has the 14 and the 3. So it has to have the same average coming up here. And then it also has to have the same standard deviation, also hence the same height of the graph as the speaking. So when we draw this, we're going to come down like that, and then for the other one, make it look a little bit symmetric. We're going to come out like this. Okay, going back to the federal government here. So the federal government health guidelines recommend that children who are not speaking by the age of 24 months should start receiving funding. All right, so again, we're going to have to do another calculation. We don't have much space, but so this is for speaking. So speaking has a 17 mean, and then we're trying to find that tail again that's greater than 24 months. So for speaking, and we're doing this because we want to compare. Sorry, I should have said in the question, we're comparing speaking to walking, but we have to do the calculation for speaking first because we've already done the walking one earlier. So it's the probability that X is greater than 24. So from our one here, we're going to just change that tail to 24. And it is for speaking, which has a standard deviation of 3. I think, sorry, let me just quickly walk up here. So speaking, so 17, and then a 17. All right, so a little bit of a tricky one here. So we've got 9.8, and then that E is the same as saying times 10 to the negative 3, but you can't leave your answer like that. You've actually got to convert it, and when we convert it to a decimal, it's 0.00982. Now, if you're not 100% sure where I've got this from, you kind of go where the old decimal was, which is between the 9 and the 8, and we can see 1, 2. We've jumped 3 units because of this guy. But the question, we're going to convert into a percentage anyway, because our previous calculation we did was a percentage, so it's 0.98% receive funding. Now we are comparing the walking and the speaking, so if we come back, we have to flick back a page, but up here, this is what we're comparing it to, right? So this is the federal government again. And he's saying that for required assistance with walking is at 4.32%. And what we've just calculated down here is for speaking is only like a 0.98% funding. So therefore, walking has more funding. Since 4.32% is greater than 0.98%. So 4.3% of children will get funding for walking, compared to only 0.98% for speaking. So you're more likely to get funding for the walking.